All right, for this video, you have been given a note taker on rate of change. We will complete the front side together as your examples and instruction, and then prior to coming to class, you will need to complete the back side, right, following the same examples and the way I do them on the front side. All right, the first thing we want to take a look at the box at the top, it tells you how to find the rate of change between two ordered pairs. I want you to ignore that. That is more Algebra 1 material, and that formula is just going to be scary and not important to you at this point, and there's a faster way that you will understand and that will make more sense to you. So that's what I want you to use, is the way I'm going to show you, not anything about that formula at the top. You will learn that formula and have to memorize it in Algebra 1, so that'll be next year. Right, but for this year, rate of change is going to be how fast something changes over time. Time is always involved, right? And the way we're going to do this is we're going to make a t-table, right? And a t-table literally looks like a T, right? And the headings are going to be your X and your Y values, right? But instead of just X and Y, you're going to have situations in your pictures or in your problems that you'll have to identify. So X is always time, and if you look on our graph over to the right, this is Mr. Jackson's income from the year 1994 all the way to 2002, right? So looking at the graph, the years are your X values. So above the X, go ahead and write the word years. Okay, and then for the Y values, your Y-axis is labeled annual income, which is basically the money he makes during those certain years. Right? So the way we want to set this up is to set up a table and then use that table to help us do the math that we want to get an answer from. So if you read the problem, it says that the graph shows Mr. Jackson's annual income between 1994 and 2002. Find the rate of change in Mr. Jackson's income between 1994 and 1997. They will always give you the two values that they want you to find the change between. Right? If they don't, you can't really do the problem the way it's meant to be done. Right, so because 1994 and 1997 are the years, those are our X values. So we put 1994 and 1997 on the left. Right, but then we have to go to our graph and find what are the Y values that go with those numbers. So if you go to the graph and find 1994, that's this ordered pair right here, 1994 and 48,500. That 48,500 was his pay in that year. Right, then if we go to 1997, which is right above it, this is the order pair for his pay then. So in 1997, he made $53,000. Okay, and that's setting up your table. You will always set up a T-table that looks like this. Your headings will be words and symbols, not necessarily X and Y though. Right, so as we go through, we won't always use those letters X and Y. Right, so when we're looking at this, we always want to ask ourselves, how are things changing? How much does it take to go from 48,500 to 53,000? Well, you're increasing, so that's a plus. Anytime you increase, you need a plus. Anytime you decrease, you need a minus. Right, now you have to figure out, how much am I increasing by when I go from 48,500 to 53,000? So you can take in the calculator, or you can take mentally, and you can subtract 53,000 minus 48,500. That will give you a $4,500 difference. Okay, so to go from 48,500, if you add 4,500, you do get 53,000. Okay, so you have to figure out what is the difference between those two values. Right, you'll never have a negative unless it's decreasing. Right, then over here on the left side, how many years go by from 1994 to 1997? Well, because it's time, time never decreases, so it's going to be a positive and then 3 years go by. Right, so now that you've found how much things are changing by, now we want to set up the ratio that allows us to get the final answer, because we still don't know rate of change yet. Right? When you go to do rate of change, it is the change in Y over the change in X. That's the ratio you will always use. Right, so the Y will go over the X. Right, so our change in Y value was positive 4,500. Okay, and then our change in X value was positive 3. Okay, and then you have to divide them. Rate of change means how fast does it change? Well, you can't leave it a fraction, so you have to tell me how fast does it. 4,500 divided by 3 gives us 1,500. Okay, now because it used words, we have to have words. 1,500 doesn't tell us anything, right? But if you look at our Y values and our X values, we were dealing with money, so 1,500 is dollars, and then we were dealing with years, so $1,500 per year. Okay, you must have per something in your answer, and it will always be per and whatever the x value is, and usually it's time. Right? Another way you could write this if you want to write it differently is 1,500, the slash means per, and then you can abbreviate year. So there are different ways to write the end part, but you must have words when you use words in a word problem. All right, so now having done all of that as your foundation and your basic, let's take and apply the same concept to a different graph. All right, we are looking at wave heights, and that wave height is going to be measured in feet. It doesn't tell you that, but that's exactly what it's using. And then our days. So on day 1, it was so many feet, day 2, day 3, etc. All right, so we have wave heights going on in this picture. All right, so this is surfing, okay? And you're going to use the graph that shows the average daily wave height as measured by an ocean buoy over a 9-day period. Right? So from day 1 to day 9, this is what they measured for the wave heights. Okay? For number 1, it says find the rate of change in the average daily wave height between day 1 and day 3. Here are your x values. Right? So when we go to set up our table, right, it won't say x and y, it's going to say days, because that is our time value. And then because we're looking at the y value is the y-axis, that would be height for the y value. So we're looking at what day and how high were the waves. So we want day 1, and if you look at the graph right here where it says 1, 8, 1 is the day and 8 is the height. Okay, that's how your ordered pair is set up. Right? So that would be 8 feet tall. And then they want you to use day 3. So on day 3, if you look at the ordered pair, that's this one right here, they were 12 feet high. Okay, so now we want to do what we did before. We need to find how is it changing to go from 8 to 12, and then how is it changing to go from 1 to 3. Always start on the right-hand side first with the y values, and then do the x, because it'll train you to do y over x in the end. So to go from 8 to 12, we had to add 4. To go from 1 to 3, we had to add 2. So now when you set up your ratio, it's y, which is positive 4, we're adding 4, over x, which is plus 2, and then we have to divide. 4 divided by 2 is 2, but if you leave me with nothing but 2, that tells me nothing about this problem. I need to know 2 what, right? So that's when you go back to your table. It is 2 feet, because that's how high the waves are moving, per day. And you can get those words from your table. Okay, so every day in between day 1 and day 3, the waves increase 2 feet per day. Okay. Now number 2, we want to find the rate of change in the daily height between days 3 and day 7. So same picture, but now we're setting up the table with different values. You're still going to have the day for the x value and the height for the y value. Okay, but this time we want day 3 and day 7. All right, on day 3 it was 12 feet tall. Okay, and then for day 7, that's up here at the top where it was the highest, that was 14 feet tall. Right, so how do we get from 12 to 14? We add 2. How do we get from 3 to 7? We add 4. Okay, so now setting up y over x, that would be positive 2 over positive 4. Divide. When you divide 2 divided by 4, you will get 0.5. You are allowed to have decimals in rate of change, right, because you have to divide. Right, and it doesn't make sense to say 1/2 something per something. Right, we always use a decimal or a whole number. All right, so 0.5, and again we need the words feet per day. So in that time stretch, things only increased 1/2 foot, so it was a little slower then. Right, now number 3 says find the rate of change between day 7 and day 9. So again, same table setup of days and height. This time we're using day 7 and day 9. Okay, and if you look, day 7 was 14 feet tall and day 9 was 11. Now if you do some observing from your graph, you notice that at this point of the graph, things aren't going uphill anymore. Now they're going downhill. They're decreasing. So anytime something decreases in math, that's where the negative sign pops up. All right, so when we go from 14 to 11, we're not adding anymore. Now we're going to subtract 3. And then to go from 7 to 9, we're still adding 2. Right, so then when I set up the ratio, it's going to be negative 3 over positive 2. Okay, and now we want to divide. Negative 3 divided by positive 2 is negative 1.5, and you still need your words, feet per day. Okay, and what this tells us is that between days 7 and 9, the wave heights were decreasing 1.5 feet every day. Right, so we can get this information from using the numbers in the table, as well as using and observing what the table has for us. So now your job is going to be to complete the back side of this table. You have the back side of this worksheet. You have some different information in a table format as well as in a graph, but I want you to see what you can do based on understanding the examples that you've been presented.